function are studies. So basically, it is a one of the generalizations of the k beta and k gamma function, and we have used the particular mathematical package to understand the behavior of the functions which were based on the quadrature formula of Gaussian type. Okay. So in the introduction, basically, as you see in the equation 1.1, this is the classical k gamma function defined by the equation 1.1, where k is greater than 0 and real part of nu is greater than 0, as well as the Pochamber k symbol, which is given by the nu and k, gamma of k, nu plus nk upon gamma of k nu, which is a 1 when n equal to 0 and nu belongs to the as per the condition, and nu plus k up to the nu plus n minus 1 k when n it belongs to the natural number and nu belongs to the c, and provided several identities like gamma k nu plus k equal to nu gamma k nu gamma k minus nu equal to pi upon psi sine pi nu by k. And also they define the k beta function, which is given by the equation 1.2. You can see that at here, it is a beta k nu 1 nu 2 1 upon k 0 1 t raised to power nu 1 by k minus 1 1 minus t raised to power nu 2 by k minus 1 dt. So after that, at here, we have used the relationship between the k beta function and the k gamma function, which is given by this particular interesting formula, is very similar to the classical beta function. However, all these results are a co-sequence of the relation, which is given by at here gamma k nu equal to k raised to power nu by k minus 1, gamma of nu by k, and properties of the standard gamma function. The generalizations of the classical spatial function began in the early 1990 by the one of the research group by the Chaudhary and Jubair from the Pakistan, have extended the classical gamma function in 1994 first time, which is given by the equation number 1.3, gamma of nu 1 as 0 to infinity t raised to power nu 1 minus 1 e raised to power minus t minus st raised to power minus 1 dt, and the convergence conditions are given in equation 1.3. Later on in 1997, Chaudhary et al. And his research group, they have extended the classical Euler beta function, which is given by the equation number 1.4. Here you can see that they have used the one of the new part, that is the exponential function. They have incorporated the exponential function in the integral and generalized the beta function, which is given by the equation number 1.4. The convergence conditions are given at here. In 2021, using the two-parameter Mittag-Leffler function, me and my research group, we have introduced the ES1, S2, Z, the extended classical beta function, and which is given by the equation number 1.5. You have seen the comparison between the 1.4 and 1.5, then you find that we have generalized the exponential function by the ES1, S2 minus S, T1 minus T whole raised to power minus 1 dt. And the convergence conditions are given at here. So that is basically E of S1, S2 is the general two-parameter Mittag-Leffler function. The convergence conditions are given at here. Motivated by above all extensions of the classical beta and gamma function, Shahid Mubin from the Pakistan have introduced the extension of the k gamma and k beta function by using the exponential function, which is given by the equation number 1.6 and 1.7. Here you can see that they have used the k beta function and they have used the sum of the modification in the gamma function definition and the beta function definition by introducing the exponential function inside the kernel. After that, if we set s equal to 0 in equation 1.3 and 1.4, the 1.3 and 1.4 are these two definition by the Chaudhary and Jubair, then we get the k gamma k beta function respectively as follows, which is given the conditions, and these are the results we can get when we put the s equal to 0. To obtain our main result, we need the define we need to define the new K Mittag-Leffler function as follows. It is represented by EKS1, and the representation is by the summation n equal to 0 to infinity z raised to power n upon gamma k n s1 plus 1, where k is greater than 0, real part of s1 is greater than equal to 0, z belongs to the complex number. And E of k S1 S2, which is defined by n equal to 0 to infinity z raised to power n upon gamma k n S1 plus S2, where k is greater than 0, real part of S1 is greater than equal to 0, and real part of S2 is greater than equal to 0. Z belongs to the C, which is given by the equation number 1.8. Here I remark that we consider the variables S1, S2 equal to 1 in the above equation, then we get the k exponential function EKZ. So in this work, we have defined the new numerical method for classic calculating beta k nu 1 nu 2 s on based on the quadrature formula of Gaussian type is presented in section 2, while new extension of k gamma k beta function and their property are given in the last section. So first of all, we discuss about the transform the integral form 0 to 1 to the symmetrical interval minus 1 to 1, which is given by this equation 2.1. Here you can see that there is a two kind of the representation of this transformation. Number one is the bk nu 1 nu 2 s, which is given by the right hand side, and similarly the second part is given by the 1 upon 2 raised to power nu 1 plus nu 2 upon k minus 1 minus 1 to 1 1 plus zeta nu 1 by k 1 minus zeta nu 2 by k wk zeta s d zeta, where zeta is belongs to the wk zeta s is an even exponential weight function with essential singularities at plus minus 1, which is defined by the equation number 2.2. So the beauty of this particular result is that we consider the matter of for numerical calculation of the extension of the k beta function, which we have extended in the equation number 1.7. In 2.2, you can see that this is the weightage function, and it is defined by the 1 by k, 1 upon 1 minus zeta square exponential function minus 4s raised to power k upon k 1 minus zeta square, right? Then we want to construct a quadrature formula of the Gaussian type with respect to the weight function 2.2, and which is represented by the equation number 2.3. So this is the quadrature formula with the help of the Gaussian type, and we have established at there, and the where zeta and nu and a and nu equal to 1 to n are the node and the weight coefficient respectively, and r and f is the corresponding remainder term in this quadrature formula, which is 0 for all algebraic polynomials of degree at most 2n minus 1. In order to thus construct the n points Gaussian formula 2.3, we need a sequence of polynomials pi j orthogonal on minus 1 to 1 with respect to the even weight function 2.2. Preciously, we need the recurrence coefficient beta j equal to 0 to n minus 1 in the three-term recurrence relations, which is given by the equation number 2.4. Pi j plus 1 zeta equal to pi zeta pi j zeta minus beta j pi j minus 1 zeta j equal to 0 1 to n minus 1, and where the pi 0 zeta equal to 1 and pi minus 1 zeta equal to 0, then we construct the corresponding symmetric 3 diagonal Jacobian matrix, which is given by the equation number 2.5. So this is the beauty of this particular analysis, where alpha j equal to 0 and j equal to greater than equal to 0 due to the priority of the weight function 2.2. Its eigenvalues are the nodes zeta and nu equal to 1 to n, and the weight coefficient Cotes number a and nu equal to 1 to n can be obtained from the first component of the normalized eigenvectors corresponding to the eigenvalues. Such an algorithm was obtained by a simplification of QR algorithm by Club and Walls, and the Club and Walls algorithm is implemented in the Mathematica package, right, which is mentioned in this particular website. If you click at there, then you find the free download from the website. In order to construct the coefficient beta j equal to 0 to n minus 1 in the three terms recurrence relation by 2.4 by the modified Chebyshev algorithm. We need the first 2n modified movement, which is given by the equation number 2.6. Here you can see that mu j equal to minus 1 to 1, pj zeta, wk zeta s d zeta, j equal to 1 to 2n minus 1, where the sequence of the polynomial pj is chosen as pj zeta, zeta square minus 1 raised to power j by 2 when j is even, and zeta into zeta square minus 1 raised to power j minus 1 by 2 if j is odd. That the moment of odd order are equal to 0, that means mu j equal to 0 if j is odd. These polynomial pj zeta also satisfy the three-term recurrence relation, which is given by, this is the first relation when the condition is given, when alpha j equal to 0, beta j equal to 1 if j is odd, and beta j equal to 0 if j is even. For finding the modified moment for even j, we consider the integrals 2.6 on 0, comma 1 and introduce the change zeta equal to cos theta between the 0 to pi, so that mu j is represented by 2 0 to 1 zeta square minus 1 j by 2 wk zeta s d zeta, and this is represented by the in the resulting 2 by k minus 1 raised to power j by 2 0 to pi sine j minus 1 theta exponential function minus 4 sk upon k sine square theta d theta, where j is belong from the 0 to 2n minus 2 by the 2.7. And when figure 1, we represented the graphic of the weighted function from zeta tends to wk zeta s on minus 1 to 1, as well as the function theta tends to wk theta s sine theta wk cos theta s on 0 pi, and we got this beautiful result. Here you can see that in this comparison, the graphics of the weighted function wk zeta s left, I mean this one, and the capital wk theta s right, this particular graph for k equal to 2, s equal to half, red. You can see that this one. This is the red line showing at there, and similarly red line at here. And k equal to 1 and s equal to 1 by 8, blue line. This one. This is the blue line. Okay. And this is the blue line. And k equal to half and s equal to 1 by 32 is the green line. So you can see that at here, this is a green line showing at here in the both the graphs. So by the so-called measure z function, this is the classical definition of the measure z function. I'm not giving the more information at here about the g function due to the time limit. The measure g function is implemented in Mathematica, where the code is given by the measure g a1 up to an, an1 up to ap, b1 to bm, bm1 to bq up to s, and it is suitable for both numerical and symbolical computation using Mathematica 13.3. We get this proposition 2.1. The modified method 2.6 can be expressed in terms of the measure g function. So when we implement the measure g function, the result is becomes in this particular form. Okay. Now we are ready to apply our Mathematica package and construct the first 50 recurrence coefficients beta k denoted as the sequence b. This is the coding of the Mathematica, which is given at here. And after this particular coding, these 50 recurrence coefficient are obtained by the maximal relative error 6.99 into 10 raised to power minus 35. So using the working precisions of 50 decimal digits, notice that for calculating this maximum relative error, we need to repeat computation with some
Excuse me.
better
Ex-
precisions, that is with 80 decimals digits.
Hello.
Yeah. Yes, anyone?
Uh, Hi, Praveen. This is Murat Sari.
Yeah, yeah. How are you, my friend?
Thank you very much. When I saw you, I thought that a day is 48 hours in India.
Yes, 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 yes,
Because you
yes,
are
yes.
very hardworking, so I don't know how you are increasing the hours of the day.
Not at all, my friend. I'm trying my contribution like
Yeah,
you. So I'm
of course,
really
it's a
sorry for
joke, but
that
just I
delay.
want to remind you, you got another 6 minutes to finish. Thank you very much.
Okay. Okay, okay. I'm going to the directly the
Yeah,
main result.
yeah,
Thank you very much, my friend. Okay, okay,
great.
okay. Thank you. So now we see the proposed numerical method for calculating the function B beta k nu 1 nu 2 s is very efficient and represent the first method in the literature for the numerical evaluation of the values of this type of function, which is given by this beautiful graphs. You can see that here. So the figure function nu1 is beta 2, nu1, nu2 half for nu2 equal to 1 by 3 and nu2 equal to 1. In the blue line, you can see that at here, this is the blue line and nu2 equal to 3 by 2. It's a green line. So you can see that here. So this is the first time we have implement this particular method at here. And number of we are if we are talking about the errors, the number of nodes which is given by this particular graph. So figure 3 relative errors, new one is error 2, new one new 2 when it's a half, for nu 2 equal to 1 by 3 in log scale, for nu 2 equal to 1 by 3, k equal to 2 and s equal to half. So these are showing the red lines and showing the error of the particular method which we have calculated with the Mathematica. So numerical calculation of the extension of the k gamma function can be done in a similar way. Now, this is the next part of my presentation in which we have discussed the new extension of the k gamma, k beta function and their properties. So I'm just going to the directly the new k gamma and k beta function very fastly. Just give me a few minutes. So a new extension of the k gamma function, which is defined by the equation number 3.1. So here you see that we have modified our Mittag-Leffler function in this form. And the reason behind that, when we have checked the numerical calculation of our results with the Gaussian method, then we find that it is required to some of the modification to reduce the error. So that's why we have modified this particular k gamma and k beta function, which is given by the equation number 3.1, and new extension of the k beta function, which is given by the equation number 3.2. You can see it here. So here we have modified our Mittag-Leffler function, and these are the convergence conditions. If we consider variable s2 equal to 1, the above definition, then 3.1, 3.2, then we get another extension of the k gamma and k beta function, which is given by the equation number 3.3 and 3.4. Here you can see that if we put the s2 equal to 1, then we got the 3.3 and 3.4 respectively. In 3.1 and 3.2, if we put the S1, S2 equal to 1, we get equation number 1.6 and 1.7 respectively. And that's we have the motivation of this extension of the k gamma and k beta function. As I mentioned that when we have used the numeric Gaussian method and calculate the analysis, then to reduce the error, we required this modification. Basically, this is the main motivation. So that's why we have modified our own extended cable. So this is the main reason we have modified it. And now I am directly going to the some of the definitions. This is the theorem 3.1, the extended k beta function defined in 3.2 satisfy the following symmetric relation, which is given by the equation number 3.5. I am not giving the proof at here. So this is the extended k beta function defined 3.2 satisfy the following functional relations. When we study the new extensions of the spatial functions, then these are the basic properties which is required to understand for the understand behavior of the functions. Okay, which is given by the 3.6. And this is the extended k beta function defined in 3.2 satisfy the following finite summation formula, which is given by the 3.7. Okay, and at the same time, the extended k beta function defined 3.2 satisfy the following infinite summation formula, which is given by the equation number 3.8. Okay. And the extended k beta function defined in 3.2 satisfy
Excuse
the
me,
following.
Praveen.
And yeah, oh, yeah,
You got
just
another
I'm
extra 2 minutes from me.
okay. Thank you very much. Thank you very much.
Okay, this is
I'm
this is just for you.
yeah, many thanks. Many thanks, Mohammed. It is really
Okay,
great.
wait.
You are so humble, so humble. Thank you very much. So I just show to the one of the very important result, which is very important in my point of view. I'm going to the yeah, just a moment. Yeah. So The following derivative formula holds true. The derivative formulas are important when we are dealing with the mathematical model. So that's why, in my opinion, the derivative formulas are important, and we have derived the derivative formula for our extended beta function, which is given by the theorem number 3.14. So those are interested to study my particular results, then they can use this particular derivative formula to analysis some of the new mathematical model, especially in the water resources and the some energy equations. So it will be effective because we are working on this direction. And now I am going to the showing one more interesting result. This is the Malin transform of the extended k beta function, which is given by the 3.24. So to understand the behavior of the contour and the divergence conditions of the function, the Malin transform is also very important in my opinion as a being of the spatial function person. So you can also see this particular function at here and study the main properties and the divergence and convergence and poles and residues with this help of this particular formula. So thank you very much, all of you, for giving me wonderful time. And we have proposed a very efficient algorithm for numerical calculating the values of the function bk extension of the k beta function based on quadrature formula of Gaussian type. Secondly, we have introduced new extension of the k gamma k beta function by using the two parameter k metaglipper function as the kernel in the integral definition of the k gamma function and k beta function. Then we have studied the some basic properties of these extension with their special cases. And this paper is already, we are very thankful to the Professor G.B. Melkosi for the support of and guiding me to develop this particular result. This is published in the Applied Mathematics Computation, and thus the extension work is under the pipeline. They are going to publish soon. These are the references. So thank you very much once again to the organizers. They are so humble to giving me a time to present my talk. Thank you very much.
Thank you very much, Praveen. I think you and the audience will remember Mr. Bean, yeah, comedian, English comedian.
Yes, 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 yes.
Yeah. You know, one day he's in the hotel and he can't sleep easily, and he saw a picture on the wall, and there are many sheep in the photo. Because of sleepless night, he's trying to count the number of sheep.
Okay,
And
okay,
yeah, till morning, he's trying and trying and trying. So therefore, I don't, and he's giving up counting the sheep.
okay.
Yeah. Therefore, in the same way, I give up counting your papers.
No, 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 my friend. It's just I'm trying to
No,
contribute some
no,
of the
don't be
work in
so
the field of
modest.
the
I know
scientific.
you are hardworking. So I am glad to speak to you personally as well. Also, the audience are happy to hear and to listen to you here. And
Thank you
glad
very
to
much.
see you. Is there any question, ladies and gentlemen, to Professor Agarwal?
Yes, yes. Can I ask?
Yeah,
Yes,
please,
please.
please, my friend.
Okay. Good morning, all. Thank you, Professor Praveen, for this
Thank
nice
you,
talk.
Professor
Actually,
Abdul Jawad.
maybe in your talk you answered a question I came to answer before, because I noticed that many editors or some editors in some journals were not did not like the extension of the k beta extension, k beta function, and always they asked what's the novelty behind those functions. So as far as I understood from your talk, that the reason is not only the extension itself, but maybe there is numerical reason. What do you think? What's the novelty that we can add when we use k beta and gamma function, k beta functions?
Yeah, thank you very much, my friend Tabit. Yes, it is a really very, very important question to mathematical community. The reason behind that, as a being of the mathematicians, we always try to find out the solutions of the problems. and the second thing is in our mind as a to reduce the errors. Okay, so in my
Yes, this is
opinion, personally, I try always to reduce the errors. So that's why if we can show the sum of the options to generalizations or maybe the extensions or maybe the some another technique, then I have always applied. So this is the nobility, because in these days it is a time of the innovation and entrepreneurship. So innovation is what, if we are talking about the one of the mobile phone and someone is
mhm.
change his particular location of the camera, that is called the innovation. Okay, so on the same similarly as a being of the mathematicians, we are also what we are doing, if we are reducing the 0.001% error of the any analysis, then in my opinion it is a noble work. So I appreciate
Yeah.
all the extensions and generalizations always.
Okay, thank you, thank you. This talk will be very useful for those who are working in K beta and K beta extension functions. You will notice many authors are working on this, so it will be useful for them to add this motivation or to insist on this in their introduction, so that the editor can send their articles for review.
Thank you very much, my friend. Thank you very much.
Okay, thanks, thanks.
Okay, thank you very much for your question as well, Professor Sabit. Okay, any more question, ladies and gentlemen, either online or offline? Okay, I think what is the meaning of your last name, Praveen?
My last name is
Etymologically,
basically
maybe hardworking guy?
I appreciate your sense of humor. So basically, yes, you can consider like that.
Okay, thank you. Thank
Yeah,
you.
thank you very
Have,
much. Thank you very much,
have a nice
gentlemen.
day.
And yeah, thank you very much. And once again, I apology for the delay joining due to the network issue. Thank you very much. Thank you very much.
All the best. Keep smiling.
Thank you. Bye bye. See you.
Bye bye.
We would like to thank Professor Dr. Praveen Agarwal for an enlightening presentation and Professor Dr. Russell for sharing the session. Dear participants, welcome to Secretary of International Conference Mathematics and Applied Data Science 25. Yesterday we had a virtual and inspiring day with valuable sessions today, another exciting and speech program data. Before we begin, I would like to take a moment to emphasize the significance of today, August 3rd, Victory Day in Turkey, which marks a turning point in our nation's history, symbolizing independence, unity, and resilience. On this meaningful day, we honor and sacrifices made for freedom and sovereignty. Now, I probably invite you all to stand up for a moment of silence and to sing our Turkish national anthem. I wish everyone a productive and successful day ahead. Please stand up. We will now proceed to explanation 4. The title of this lecture is Algebra Equations for Finished Fields and Necessary Solutions Techniques and Practical Impacts in Building Theory and Spirituality. Session 2 is Professor Dr. Sihem, and our distinguished speaker is Professor Dr. Sihem. I now pass over the floor to our signature.
Hi everyone. It's not working. Hi everyone. First of all, I would like to thank you all participants and supporters. Now I am really glad to introduce my supervisor, Sihem from Praveen University. First of all, I would like to extend my old special thanks for accepting our invitation to give this talk in this our first conference. She's a she received PhD in Sorbonne University in Maths, and now she's a full professor of mathematics at Harvard University. She's working on mathematics and especially the applications in coding theory and cryptography. She is actually, as she said, she's very distinguished researcher in this field. And also, she has amazing career in this field. She published 3 books, 150 papers in journals, international journals, and 60 proceedings, etc. She has 5,000 patients in this field. She has first prize, which is International George Boyd Prize, and also he has a lot of many academic activities, etc. Now, I would like to thank him for coming to our conference. Thank you so much. The floor is yours. Thank you.
Thank you so much. It's great. First to know you and to work with you. It's really, I cannot forget this always brilliant and continue. So thank you so much for all of you. First for being here today to listen to my talk. It's a little more algebra than this. And thank you so much for this wonderful invitation in which I saw more your country, lovely country. Thank you. And meet lovely people, also amazing organization. Thank you so much. Sorry, I don't have much time. Merci. Thank you. Okay. So I speak about equations. I took this topic first it's very important, and anyone can in mathematics can understand algebraic equations. So it's the impact in applications is enormous. First, we focus on 2 applications. The first is related, of course, to the conference data. The first is about secure communication, secure communication data, and the second is storage. And this is and then keep impact of some equation. So let me introduce the outline first. I would say what is the motivation here? What one be why we are doing this and why to which program specific is in. And then I will give specification of the which is very much very speaking. And so I will explain why this is for solutions of analytics interesting to evidence linear curves and the random functions. And then I will say a bit about the impact of current specific curves, the storage data, and the random functions as the bank ingredients it gives them to secure security data. After all this, so bad and motivation, correlation with the mental because these applications, I will go and give a short, it will be very fast, what we know about polynomial equations, how in terms of solving them. We see that it's, we don't know yet. Almost is about you and there's no anything and except very specific easy case. And I will focus this equation x to p the thing plus 1 plus x plus a 0 or the analytics for other p and this is a line and is a picture and a is of course not equal to 0. This equation we discuss this equation because this equation has a big impact and has been solved between 2020 and 2024 and they explain all the strategy and the approach and the impact by solving this equation was we know for a long time number of the solution of this equation by complex solutions and the number of solutions has been proven and dated by Netanyahu Sloven like this working in number theory in real estate is and thanks to composition utilization of power in two variables, we can obtain this solution of this issue, which has been a long time open problem. So let me start. So when we say so we should have specified this kind of equation. So here one interested in polynomial equations. It's not a specific polynomial equation. And over the fit and the fit here is the finite fits. So finite fits, you know, it's finite, have a number, finite number, and then the finite, and we know that it's necessarily the power, and that is necessarily power of prime, and so it's a prime, and we know how to construct this through by fitting the polynomial over the C over C, and in which the polynomial is here, and of the n of the finite up to isomorphism. Okay, so this is our will not be anything finite. And why? Because when we transmit message and we protect data, the message are from attributes, and that is finite. And that's right. And we want something with a very strong structure, algebraically speaking. So we want to not care about the environment, provided it's not equal to 0. And we have for free, if you have a big field or a small field, in fact, it's a sub-field, prime field. It's a righteous field. We have necessarily a section of the vector space of the big field over the small field. So we have an algebraic section of vector space and finite field, and it's finite. And that's why we love this. And impact financials has been developed introduced by, we say the kind of it's very, it's Agarwal, who is born in 1811 and 18 Paris. And he died in the age of 32 years old. As you know, French people accept to die with love. So it was a time he died fighting against Agarwal education. And in his, before he died, he sent, so very before, it's in 1811, he sent him later, like his hand, and in the vision, and he said, okay, in the years later, to France, the previous years, I attended a lot of results to take all of them to write even the proofs to you things later, but I think that it's okay, it's no problem. However, there's something I want to do. So here's two men, one friends, one of them said it's about the application. So in 18 that time, if I say well, it's thinking who discovered an amazing approach of thinking about applications of financials. And later, this financials is called the value of it. So that type of application. So application is very important, but to apply something, we have to have theory, definition, and it's very important. So we are looking to add for application in the model declaration. And this kind of something is very important because we need to all together to get progress with our own achievements. Thank you for this. Now, I'll fix management equations of all financials. Okay. So what is it about? It's about the first of all, some equation. It's very important for that by now and about that question. And because we're very limited in our knowledge base. And well, there's some action in applications and also in particular experience. So it's not for anyone young and not some days ago. I said, not there. But there's a lot to do together. Say everyone. And the application will have doing as a introduce the second this way, one of the this alien church and certainly so what do they so financial so and so and to the signature where dealing with economic equations to create when we think in general we have objects here financials. Most of the time, something is very important, it's not object itself, but the relation between two objects. So the relation between two financials, namely functions, functions, and when we think for function for a PD and a PDN is in P as a polynomial. That's why after that you have equation polynomial equation and the polynomial either in one variable or the trace function or polynomial in many variables in the degree but as a number form that polynomial but both of them are polynomials and it's a unique representation of any function from between two finance. In general, we need any, and in practice, any general equal to 2 is 1. It's in general for practice you will see that. So to be the participant, it's the only cases feasibility. Okay. So I saw this. So I explained that our meditation is solved and because our understanding is incomplete, and we want to use that extra, and it became we are stopped by the literature. So we applied use functions to integrating system security. And it's for us, yeah. So if you can do anything, information, logic, and also some conclusions. So then so secret position there and the storage to that something. But so in you can consider function that we find in any game this, but I will start with the keyword too because of the applications. If you have a function, why is this function is something? The main ingredient of a system is the data. See that the whole security of the whole system depends on one in this function. If you does not choose how you select this function, and this function is not select according to the property, internal property, and the property depends on attack. So we have attack, we attack the system. So the attack means you discover the security, you know, the press that is from the second. And the beginning of attack, we introduce a parameter function to control this attack because we want to protect ourselves. And this, of course, we have a parameter. We have to regard the attack to introduce the beginning. It's for example, we know that anything is not good. Why? Because we discussed about nominal functions in yes. Because why? Because we have an algebra. Those methods still destroy anything. So we don't know want something not because we don't want. But because in linear it's very big. And then the system, the so to be part of linear, we define a distance, and we want that the distance is big. And so here, linearity, non-linearity is the parameter, and the linearity, the linearity should be as wide as possible. Simplest way. So you have to come together. We have a parameter and figure. And we want function optimal regarding this. And for example, optimal function again the linear x is one of the most maximally nominal function and the bad functions. That's very well and it was mathematically met together in Paris. Okay. So, and this leads so together functions for any all the attacks not on one. And this gives rise to together functions. And so we can classify in fact it's not like this that's by me. And classify the primary functions, but the two major classify the two major families. First is control. So it's not any function, it's function. It's object from the integral aspect. Further go by, but we go back so far, let's speak about this. So it's the nonsense, and the was fully transformed of the sine function. And the second family is controlled by the number of solutions of certain equation. So if you want to know if your function is strong enough or not, you have to solve an equation. on the number of solutions. And according to the number of solutions, we, if it's strong or not. So everything was very specific, go back to equations. That's it. So of course, when we solve equation, it's good to solve equations, but in fact, till now, till today, it's enough to know the number of solutions to the equation, not the solution. But now we are at the end, who's the all what we know and our background. That's why I told the from the beginning, we are stopped by the literature. We cannot do step more because we need the results. So, for example, two important analysis. The first is difference attack, in which the attack is controlled by the parameters so the F, F is the function. And the F is the maximum of number of solutions of this equation, number one. So you solve the equation and solve the count. You take the maximum. And this is the F. The F, the criteria now, let's go and assume that the functions the X, the difference of that. And the lowest, the country of the number is better. Yeah, the lowest better. So the lowest value is 2, because should be even is this. And this gives us the optimal function regarding this type of so almost perfect here. APN functions. And if I look at another many together, that's is there is a hook overall, and the parameter is in there. With the L is the maximum number of solutions of this equation. And the lowest value of the L pattern is your functions with the value of this pattern. So everything is controlled by the number of solutions of equation. The equation is called F. F is polynomial because it's from the beginning that I was as polynomial. Here, it's a polynomial thing. It's in fact that here you use the two equations. And it's also one, so it's good, but in fact it's not. Even it's not bad. So families are born by equations solving, and we know we want to know some equations, and this is for if we have secure data, the group equations. I have how many I have there?
Vous avez 7 minutes.
Okay. So now, no. So now go. It's the one that that's entity, and the development of the energy of the groups for good words, and the direction that as some space of increase power run, and the linear distance is two words. Okay, so it's not the directory, but understand control the quantity parameters. And what you want first, those parameters. The parameters is that the parameters should this parameter and maybe try some equation equate. When the equate is became ultimate, and the ultimate give rise to whatever good is good. But for good also applications. And when the applications, so, and another thing that is important is to document the weight of the words. The weight is defined as 4 of the 8 elements. And because I explained some more, the weight, so how many is possible, so how many, what is the value of the various words, the handling words, and how many times because this varies here, and this is two questions which ask to solve equations. Number of solution observations because we get up to those set code with the functions. This, I think, the main topic of Ahmed in his thing. It's okay. So the picture of functions I discuss. We can construct code, LS code, for example, local codes in which we have a data, and when we store the data, we can use information. If one bit one, we can see by error, it's finished. That is not the same. And so what you want, we don't know you want to copy the data. Save the data, to store the data. So what you want, what you do, we use codes. There is a technique tutor tableau français, and many things, and Barthes and Sonderback, the one that citate, who given method, how method is speaking method, very good method, using the genre, but in which we can recover the data to use supposedly something called the events. So okay, so back to your observation. So and the head the to some equations are these don't know the application these equations. So now the last part is equations. That's it. Okay, equation and the equation. What you know? What you know? You know, sometimes we know everything. You know, oh. Think, in fact, the equation, the one equation is classified by the degree. So the degree one, yeah, fortunately, you know how to solve. But that is okay. Yes. When we take P is equal to P equals to 1, it's x to the 2 plus 1, so it's equal. And this is what for specific P or IPDL, yes, but not in general all the solution. From this, all the solution. So even if this is in consequence, you can imagine that the one are able to solve 20 minutes, 5 years ago. And this is what they could ask. If we can be solved for any game, any M, for any. So, and so what you know for is organization, why these equations are possible. So equation polynomial, and the polynomial involved here is A, so x is 2b plus 1 plus x plus A. And you want to solve this, I will give the approach when p is equal to 2. And when k and n are co-prime. We know from the literature that the number of solution is either 0 or 1 or not because the derivative of p and a lot of people worked for a long time to solve this equation. So for a long time we know how many, but we don't know the solutions. Okay, so so we need, and this is very beautiful because the fact that all things was existing was in the literature. We didn't introduce anyone, but of course, that was the idea and the introduction. So first of all, we have to go through solve this P(x) equals 0, and the first ingredient is one pixel polynomial. This one there is a two. So just solve this. One defined by this equation expression. A is a parameter, x is the indeterminate, and k is the can prove that it's a balance. Very wonderful, very wonderful family of polynomials, and there's a lot of property, and use meta, it's further the second one is speed. The expression is very complicated, but it is also defined by different location of the order two with two each values. But it's so easy. In fact, we use the property, but not the expression themselves. And the second problem is very interesting. So the experiment. So the problem is this is very important relationship and have so in fact there are specific cases of the well, I mean, the case where complex number. Okay, the second degree that I use is reactive materials. In fact, which defined as it's complete, so this one. And this has been studied material property. When K is odd, we know that it's a repetition. When K is even, so the quality of the of the variant depends of the variant K. When K is odd, it's repetition. When K is even, it's one. And you zero of those solutions. Okay. Let me start. So we have this equation, and we suppose that K is out. We start by this. First, when K is out, 2 K minus 1 is 4 minus 1. We are the case with K and N alpha prime. A simple case, but and so since K 2 to the K minus 1 is out, x to the 2x minus 2x K minus 1 is the permutation of course. So x to the d is the permutation of an PDF combined with x. And this permutation, we change the variable, we have x on, and for any a is this is a new unit so that we have this a equal to this. In terms of people have going matters, because in this case, for K on that going matters is the permutation. So there is no solution. So we change A by y, where y now, and we write, we have the B8. So the equation 5. We can rewrite the equation 5. Then with x and y, x out x and y equal to x. And this is equal to 0. So this, the first and the left side, is a common 2 and x and y, and really that can be out as given the composition factorization of this polynomial in the left of its polynomials. It's very wonderful. The paper is in archive and not published. I think that this is saying cannot publish. And so this is equal to 0, so that equal to 0, we are free, so each one this means that this product, this is a mean that we have to find in somehow the measure of the mix about. So when these finding the solution is the amount of the solution, and we have to first determine the measure of line and then the mix of parameters. It's it's about it's on the great message or other papers. Okay. So when K is even, this because x is x by y, and through the reactive materials, and this case, when K is odd was a permutation, and now it's not a permutation, it's 1. So go back to the equation and it's from the beginning of 0. And we make this form. In fact, we see that it's exactly the same equation. we write in, but we get n minus k, and x we get x plus 1. So, and because otherwise we have to find another approach with this. And this is good news that when k is even, n minus k is odd. So well, exactly the same situation as before. We just replace k with n minus k, the x here, and x with x plus 1 at the end. So all story among the solved is for it's odd. Okay, so it's the answers. So I summarize the discussion. Given A is given the given A, we have to find Y through the reactive reduced, this where this is even, remember that you can find the unique expression, and given Y, we have to then C, which is the big mesh of its requirements to be able to analyze. So the third is still the problem of finding the solution. Two steps. The first A, you have to apply A given Y constants, and then we found all the solutions. So this is now a help tentacle. That's very nice. I mean, I've done the same things, but so we solved all of them. Why we use what the idea is, which use the composition of phonetic essential facts. Very well, bigger and products of the one that I told you before. Both very nice. So there's a lot of math. Okay, so solution of this in 2004 we know how many. And in fact, with this, so it's located and end combined first when it's equal to 1, 2, and then for each. And then you remove the k and then combine to the solution is not the same. When you get when you move from p, how much is p equal to 2, and in case you add, sometimes you just right here now, there's another, but they have mentions also. Okay, so we saw completely this equation. And we have also the answer that by knowing these solutions, you have proof of certain APM algorithms, maximum optimal difference uniform functions, and proof in the two lines we have assembly functions, and basically this is like the modeling. There's 7 papers showing that the assembly should give them things numbers to 2016 they introduced a function which is the exceptional function because this function is optimal regarding the first but the program the function is a relation, the 7 papers function, and with this equation we can show that this is a relation. So easily the case. And so there's no worry, this not to go on. So if someone appear then what we have to I want to solve which case against you interested in this one case is the case, for example, you can consider the function, the equation, the function, the x is one is the other the actual form. Yes, so this is what the now and then there is this also many results after this. So we can there is a lot of all of them are open questions. And of course the big problem of Tina is the advisor of the engineer we don't have because of time. But this is not needed. There is maybe another kind of maybe there's our approach is basically works out. So I'm happy because she is working also with the position and then just push the results. It's really big stuff. It's very nice. EMA is one of the biggest senior in the area, and he says he wants to offer us, and he said, okay, found function budgeted to this in other free process budgeted APN, so maximum transference that the expert to when n is even bigger than 6 because it provides for 6. This was 20 years ago, almost. Then now today, zero result. People are unable to exhibit for any good 8 and should be even. So, and no results. No one can prove that this doesn't function like this. So it's and there's many countries because a million of the dollars on the PhD postdocs studying. So this is what we got to think about here. So because basic equation also like the years. I don't have this to company. Okay, merci beaucoup. Thank you so much. It's very pleasure.
Thank you so much for your interesting, nice talk. Professor Mesnager presented us mathematical tools to provide secure communication, secure data transmission, and secure data storage. So we have very significant polynomials and functions, and also solving little hard equations. They are very important for our cryptography and coding theory. Thank you so much for your nice talk. If you have any question about our talk?
Thank you.
My question is number of solutions for COVID story. What about the solution? How can find the solution? Suppose we find the solution. Is it usable or not?
We found the solution for these machines.
You check the number of the solutions.
No, I don't think this. I say that in P2, it's enough to find the number of solutions of certain equation. Where we find it. You get with the attacks. The attacks as what I get. But no, it's not about the number of solutions. But of course, we have the solutions.
What did they have?
We have everything. Yeah. But no, but this is this for only one inside of it. For only very important because I don't think it's very easy. It's the country and it's a people. So after I find we have just the first step. If this was something, so the
That's good.
now we solved it. Also, because I tell you that we solved the case when now you take the things and you have it's just in fact the representation of the solutions. Yeah, you reach see that you have a better no? Yeah, what's the solution? Here now yes, we have also how to say how to fix this clearly. But you have to put on the piece and other equations are not the process. So what they want to say that the having the solution is very important. In fact, sometimes even it's just enough to find the number of solutions. Even in this case, pushing and solving It's very important. Why? Because sometimes it's also very difficult to count. And sometimes by knowing the solution, it's okay, solution. But this cannot be a solution because you know the solutions. So this is cannot be solution though I'm not counted. So look, yes,
Thanks very much.
yes, it's my story.
Oh, thank you very much.
Actually, thank you very much, and very nice excitement, nice energy, and your excitement, like a patient surgeon. So it's nice, but of course I'm a bit part of here, but what I understood at least in some sense, what couple of things I'm wondering. For instance, time to time you underline the nominality also in some cases.
Yes, because
Of course, I underlined yesterday in my talk, which is important. And I remember one of my sentences, life is not in there, or nature is not in there. At this point, I wonder the dimension of nominality, in other words, the importance of nominality, is the same way with you and me, or other way around, or some changes, one thing. Another thing here is you had a nice diagram, remember, and at the top corner, I think you say secret message and so on. Because nowadays, not only France or Turkey or any part of the world, it's the only thing, it's security. Everywhere, especially message security is very important. That's why you say secret. And what's the level of this security, especially a cryptological point of view, which is important also, linear algebra and so on. Also, my friend, we had a little discussion with Professor Merdan, that we hopefully we will do later on, depending on availability, of course. I know I'm a bit, I don't want to be for some seminar. Just one more thing here. I was wondering, a couple of occasions ago, I discussed with my friends. We always say linear codes and so on. How about the possible or hypothesis possibility level non-linear codes? Thank you very much.
thank you so much for your comments. You are very important answer for the few, of course. So your questions are also very interesting, very important on Amazon for audience and exchange ideas, and are all the time very nice. Nice people. Okay, so the first question is about the non-names. Non-names, yes, it's so important to do as the so and the maximum knowledge the function has the maximum knowledge. So this is what I want highest, and this I call best function. By the way, I want to get a big so I love this object and still, but why I didn't speak about this here because the content in the specific came not, and there's a way to compute it. So it is difficult, but there's a way to compute them, right? But through equations. That's why I didn't speak about it more deeply. The fact that non-analytic can be explicit. Thanks to the water swan, in fact, the water is a swan, and it's we have to compute everything. It's not a science, and when it's the two, so actually it's two, it's the highest minority is one parts from the max or that's to the n over two, then n should be even. And so the difficulty is the computed express results and not equal of the equation, which is not outside of the scope of the main scope of my thought. That's why. Otherwise, if you Me and the non-function, I know that it's you where they so it's the same importance as sequence. It's for the mother and the kiddo system. It's very important for to rate attacks and genetics. Genetics and the cognition related to resilience. It's a system and fundamental property. In other cases, it's and we get relaxed, it's not too much, but it's not solver. Some students like solver. Okay, so the next question is about the third question I was told, okay, code, yes, there's not we have code, but it's very complicated. You can't have codes, but they're not you know, code some dismissed with the end. So the green aspects comes from so it's very complicated because we lost and the extraction and Windows all this into dissect the code with the traces the trace of some country the next it's cannot use them but it's and this gives you time the for codes. So it's there are very few codes, but all the theory for more than 6 years, so we have more knowledge about the and aspects. And the third thing will be the second question is about I function in the second question about I use security, it has without security, security number one, security is number one, and here is the security. I explained that security depends on the very basic function, and the whole system, but then and all the other components, they depend on the chosen function, and each function is chosen according to respect to optimality related paragraphs. This optimality depends deeply on either the number of solution equations or completed analysis. So we have two results. Yes. Do you have any question? And comments? No. Do you have any questions for online participants? No. Okay. I have one question, sorry. Maybe you can answer my question. As you see, find solution of certain equations is not easy. And also finding nonlinear functions is not easy. So yesterday, Professor Sarolo and you explained partial equations and it can make what can be done, what can be achieved by AI tools. And then it's possible to find the solution of certain equations by tools, finding nonlinear functions. Sorry, thank you so much for this question. Very as you should I not expect in the question, so it's supposed he has to answer. But let me just say that nowadays this it's impossible. I mean, first to do this, excuse me, in that given or I mean, low degree, one day, one determinate, low degree, and 60 is excellent. I mean, you know, if the form has no, it just to check if the end and the prime thing is 6 months or 0 months. Oh, yeah. Look, I know, excuse me. Now, this now today, so this is enabled to go do dance in a step was nowadays maybe before. The situation. So no, I actually for example something of a fun saying so. So there is maybe of course there's many different things, but some possible it's really taking so we have to think. But because the solutions is present, it will forget start. Yeah, the how they start this part of course. And to change the variable through tips and then translation and then change all this I think that if you can do should do
I know you are provoking me, but let me tell you, first of all, yes, analytical continuously. If there is a solution or solutions of any equation, there is exists, yes, you can find today, tomorrow, or essentially, I don't know. Yeah, you cannot solve all stop in one day. This is theoretically point of view. Everyone can say that. Secondly, the AI tools, for instance, the AI tools for instance, in the kitchen of AI tools of the previous name Spirit, now XPC, one of my PhD students, first PhD students now is a doctor working in as a tutorial and so on. I know what kind of difficulties we have, what kind of directions given their team and so on. One of my PhD students among them. So I know also academically, we all of us have experience because life is and science is not like that for one day or one century. You know that. Anyway, I don't want to take a huge amount of your time, but what I'm saying here is uh, ChatGPT or these or other tools are not brought out by Gabriel answer. Okay, so human beings made them, of course, have mistakes. They are improved by human. Of course, in science, we know that even though we are working with mathematics and so on, we don't say it is impossible usually. We don't like this one. We say it is very hard. Maybe next century somebody can. Okay, thank you.
Thank you so much. One minute to say thank you so much for this. So maybe during the time gave Sylvia very question is more than Excel students because doesn't it? Social times was very important to me in my life because people complex people it's very important to pay attention. Thank you so much.
I am very happy to
See this. Yeah.
thank you so much again. You accept our invitation to come to our conference and we are enjoyable time. Thank you so much. And thank you for your classmates and our students. Again, we come to the end of this session. We have break time.
We would like to thank Professor Dr. Sihem for an enlightening presentation and Professor Dr. Amislet for chairing this session. Professor Dr. Amislet presents a plaque of appreciation to our distinguished speaker, Professor Dr. Sihem.
Okay.
Thank you so much. Thank you so much. Thank you.
Dear participants, we will now have a coffee break. The break will last 15 minutes after which our program will continue to spread more culture, several sessions facilitated simultaneously in the premises and online. And you are welcome to join the one that is best registered today. We wish you an enjoyable break and look forward to seeing you in the